All right, graphing rational functions. Of course, it's a rational function if we have a polynomial over a polynomial, which is what we have here. So the first thing we would need to do is, if you can, go ahead and factor the numerator and denominator, which you can see that I already have done for you. And we start off with a cubic, and of course this is divided by a cubic. And when we're actually done, we actually end up with this guy right here. And it's nice and factored. But the important thing to notice here is that to get to that simplified statement, this guy and this guy canceled out. Now, as you can see in step number 1, it says any factors that cancel have a hole at their zeros. And of course, x has a 0 at 0. So this actually does have a hole in it. And here the hole, of course, occurs at 0. Now, if we go ahead and plug 0 back into the one that's factored over here, we would see that we would get, let's see, what do we get here? We plug 0 into the simplified one. We would actually get on top, let's see, that would turn out to be 3 times negative 2, which is negative 6 times 3 is negative 18 on top. And on the bottom, I believe we would get negative 16. So let's see, negative 18 divided by negative 16, of course, will become a positive number, and that becomes, let's see, 9/8. All right, so let me just go ahead and make a little note there. So that actually is not, so 0 is not in the domain, but I like to keep note of that for later on. The next step that we do is we go ahead and find the intercepts for this, and of course we like to go ahead and find the x-intercepts, which would be the real zeros of the numerator. Of course, for the remainder of this problem, I will really just be looking at the function that's simplified, where we went ahead and cancel out the one with the common factors. So of course, to find the x-intercept, we can see that we do have zeros on top, which would be negative 3 and positive 2. So let me just go ahead and make a note of that. So we have one at negative 3, and of course that would be a point. And of course this would also be a point on our function. Of course, a while ago we actually calculated kind of the y-intercept. It turned out that f of 0 did turn out to be equal to 9/8, kind of, even though it really doesn't exist there. So I'll make a note here that this actually would cause a hole in the graph. Now going down a little bit further here, the next step that I like to do is go ahead and find the asymptotes for our function. Of course, once again, I'll really just be finding the real zeros of the denominator of the simplified function. And when I do that, I can see that we have a vertical asymptote at x equals negative 4, and also one at x equals positive 4. And now, down here it says, go ahead and find the horizontal asymptote. And in a nutshell, it's the ratio of the leading coefficients. Now, sometimes if the degree of the top and bottom are not the same, a lot of times I use a trick where I'll just kind of make these of the same degree by making one of them, like for example, if this was x to the second power, then I would come over here and make this 0x to the third power. And 3 divided by 0 we cannot do, so then a horizontal asymptote would not exist. But here, the degrees are the same, so the horizontal asymptote would be 3 divided by 1. So therefore, the horizontal asymptote is y is equal to 3. Coming over to the next slide, we'll continue with this, where it says, well, as you probably know, for a function cannot cross its vertical asymptote, but it can cross its horizontal asymptote. So for this particular function, I went ahead and set the function equal to its horizontal asymptote, went ahead and see if that could occur. And when I did the math right here, you probably see what I did. We actually got x is equal to negative 10. So here's a case where the function actually does cross its horizontal asymptote. Now, as it turns out, the function will not actually touch the horizontal asymptote when x is large, in a negative or the positive sense, but of course large is a relative term. And negative 10 is not generally considered to be a large number. So next thing we do is step 5, which we go ahead and determine where the function lies above and below the x-axis. So we're looking for where the function is less than 0 or where the function is greater than 0. Typically what we do next is we go ahead and find the critical values, which are the values that make either the top 0 or the bottom 0. Once again, I'm referring only to the function that is simplified. And of course what I have here is I have a number line where I broke it up into regions determined by these critical values. So we have 4 of them, so that means when I actually have my number line and cut it and put 4 vertical lines through it, it actually creates 5 regions. Most textbooks would tell you to go ahead and now get a test value, which is any value from each one of these 5 regions, and then plug into the function. I've kind of found a shortcut here. I think the easiest way to do this types of problems is to determine if the zeros that we have here are of odd or even multiplicity. You might notice each one of these factors here are raised to the 1 power, which means they are of odd multiplicity. And something that you may know, when that happens, that means the function is not going to bounce off the graph. So that means for each region, the signs of the y-coordinates for each region are going to alternate. Typically what I do is I go ahead and pick my favorite test value, which is like 1,000,000. And if I go ahead and plug in 1,000,000, then you might notice 1,000,000 will make each one of these factors positive, which means that this will take me to a positive number, and then of course the signs will alternate. All right, so now once we have that, then I think we're actually ready to graph our function over here. So I come over here and let's see, what are some of the things that we know? We know that we actually have a hole in the graph, which would be somewhere about right there at 0 takes me to about 9/8. And then we have a vertical asymptote at -4 and also at +4. We had a horizontal asymptote at 3. And we know that functions hug their asymptotes. So let me go ahead and continue graphing this. So one thing I also know is that the function will actually cross its horizontal asymptote here at -10. And we also know that when the looking at our number line that we had over here, when the graph is between from negative infinity to -4, we will actually be above the x-axis, and then it alternates for each one of these critical values. So hopefully you will see that, of course, for this to be positive, we know we will have to hug this asymptote for less than -4. It will come here across, but we know it's going to continue to hug. So it's going to come back over to here. And then our next critical values would be right here. So what do we have? The next, let's see, let me look back over here. So between -4 and -3, it's going to lie below the x-axis. So let's see. So, oh man, let's see, what do we have here? Where is -3? -3 is actually where we have an x-intercept. Okay, so we have an x-intercept, of course, right here. So we come here, and that's actually where it's negative. And then it stays above again. Let's see, looking at my graph once again, let's see. Between -3 and 2, it goes above. If you recall, 2 actually turned out to be one of our x-intercepts. So let's put that there. Comes around here, there's a hole in the graph. Comes here, and then it goes below. And then it hugs again here for above. And that should be the graph of our function. Now, of course, we can go ahead and check this out by using our graphing calculator. So I'll come over here and press the y equals button. Let me come over here also, remind myself what the original function actually looked like. Let me just bring this calculator over here so I can type it in. Our function was 3x cubed plus 3x squared minus 18x in parentheses. Now divide this by x cubed minus 16x. And now let me get good window settings. So let's see, I think we went negative 20 to 20 with a scale of 4. And then on the y, I think we went negative 15 to positive 15 with a scale of 3. So when I hit the graph button, hopefully that looks very much like what I did by hand. Now I'll just make some notes here. If I hit the trace button and press 0 for x, and notice that I do not have y being equal to anything here. That's because we have a hole in the graph. Also notice that when I hit trace and do negative 10, that's actually where the y is equal to 3, which is where we actually have a horizontal asymptote. Now notice that if I go ahead and go to the left of that, then the y coordinates are less than 3. And of course, if I go to the right of negative 10, the y coordinates are greater than 3. So that's where it did cross the horizontal asymptote. If you want to, you can actually go ahead and draw the horizontal asymptote. And if you also want to, you can go ahead and draw in the vertical asymptotes. Okay, so that's a horizontal. There's one of the verticals. I can get the other horizontal asymptote, vertical asymptote by pressing y equals. The second program, choose option 4, then 4 again. And there we have it. So I believe that looks very much like what I have